That's not it. Yeah. That doesn't sound bad. All right, so what we're looking at is hyperbolas. The definition of a hyperbola is similar to that of ellipses. For an ellipses, the sum of the distances between the foci and a point on the ellipse is fixed. For a hyperbola, the absolute value of the difference of the distances between the foci and a point of the hyperbola is fixed. So for hyperbola, they're actually going away from each other. Ellipses is making more of an oval shape. Hyperbola is actually two parabolas just going in opposite directions around a fixed point. These parts are called the branches. Now, the main thing we have is the center is h comma k. Our vertices is going to be h plus or minus a comma k, and our foci is h plus or minus c comma k. And these kind of our main points. Our foci is h. And we have these here. Now, it is also possible for us to actually have a center that is still h comma k, but our vertices is going to be h comma k plus or minus a. And our foci is going to be h comma k plus or minus c. So essentially it's just going up and down. So we can have it going left and right or up and down. Just like with the ellipse where it was stretched either along the x or along the y, these can alternate as well. The absolute value, talking about the distances and development of this. And we get our equations. So the one that we have here is our x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So it's still equal to 1. Now, nicely, a little bit nicer than the parabolas, not parabolas, the ellipses, is that these here, it's easier to identify a and b, especially when given the equation. Because since they're being subtracted from each other, a is always first. A is always going to be the first value in the denominator. So whichever one comes first, the number in the bottom is the a value, our value of a. And we still have that a squared plus b squared is still equal to c squared, so we can still find the value of b by taking the square root of c squared minus a squared. That still works. And we have the equations if it is at the origin. So these here are two different setups for these here. So our focus, h plus c comma k, and h plus minus c comma k for these here, and then we have it with h. First, standard form of the equation of a hyperbola with foci -2, -1, 2, and 5, 2, and vertices 0, 2, and 4, 2, and we want to find the equation. That's what we're going to do with this one here, and we'll do some more examples like we did with ellipses, with the different equations with given sets of information. Now, when we're looking at this here, it's going to be good to know the center, because that's going to be a good value to know so that we can get our overall values. We'll need to know a and b as well, because for either equation, h comma k, our center, needs to be go in and put in, as well as a and b. So when we look at the foci, well, the number that's changing in the two foci is the x value, which tells me that we're going to be dealing with x minus h squared over a squared minus y minus k squared over b squared is equal to 1. This is going to be the equation we're using because the x values in the foci are changing. So it's really looking at the general sets of equations in our information and seeing, okay, h plus or minus a for the focus, or sorry, h plus or minus c for the focus. That number is changing from the center, and k is staying the same, 2 and 2, so we're dealing with this one here. Now, we do know we can find the value of c and find the value of h and k. Now, k, in our case, is understood to be 2. Because for the focus, it's h plus or minus c, comma, k. K is staying the same. 2 and 2, so k is 2. So for us, this equation, I'm going to leave it. What we can fill in is y minus 2 squared in the numerator of, or the second fraction, numerator of the second fraction, however, y minus 2 squared. So we have part of it. Our vertices, 0, 2, and 4, 2. So vertices, h plus or minus a, comma, k. So we have these two parts. And we need a and c to be able to find b. Now, it doesn't matter which one we find first. We can find c first. So h plus c is equal to h minus c is equal to. So what would we say h plus c is equal to? Because one of these two vertices would be h plus c. Say 5 and -1. And I'm going to add them together because it's going to be a little bit easier to work with, because h plus h will be so the center is at 2, 2. So what plus 2 is 5? 2 minus 3 is? So c is 3. Now this also helps us find the value of a. Because when we look at the vertices 0 and 4, well, a plus 2 and a minus 2 would give us 4 and 0. So what plus 2 is 4? 2 minus 2 is? So the value of a is. So to find our value of b, we just take square root of, yep, no, you're good. Yep, square root of 5. Now we actually have all the information we need. Because this here would be x minus 2. We could have actually filled that in a minute ago. A squared, so 2 squared is. Square root of 5 squared is. We have this here. Now for ellipses, a was always the bigger value. But here, a is always the value that goes first. So for ellipses, a is the bigger value. But for hyperbolas, that's not the case, because we can have something that's more elongated or closer together. A does not have to be the bigger value. Questions on this here? And that's it. That's all we have to do to find this equation. Yep. I'm going to erase all this here so it's a little bit easier to read. Okay, so they used the midpoint. We could have done that with the foci or the vertices if they're in the dead center. That's actually probably easier. Because -1 plus 5 is, divided by 2 is, 2 plus 2 is, divided by 2 is. And this works the same way. 0 plus 4 is 4, divided by 2 is 2. Same with 2. C is equal to 5 minus 2 is equal to 3. A is equal to 4 minus 2, which is 2. Plugging it into our square root theorem, we get 5. Which is the equation we got. And this here would be the graph of said equation. Now, these here have two asymptotes, and we talked about that the other day. Now, the asymptotes are going to be these two lines that the parabolas of each of the hyperbola, the two parabolas, will never cross. For each hyperbola, not hyperbola has two asymptotes that intersect at the center of the hyperbola as shown here. The asymptotes pass through the vertices of a rectangles of dimensions 2a by 2b with its center at hk. So by joining these and putting these together, we do get these two formulas for the asymptotes. Y is equal to k plus or minus b over a times x minus h. Or we get y is equal to k plus or minus b over a times x minus h. A over b. Thank you. Don't want to have another of me miswriting something and then getting stuck later. But these are going to be our two equations that we have. Questions on this here? So, if we want to look back at the one we had, so b over a for this here, if we wanted to look at the asymptotes, well, y would equal 2 plus or minus, yep, because b in our case was the square root of 5, a was 2 times x minus 2 would technically be the equations that we have for this here for these two essential asymptotes that go across here. Questions on this here? Oh yeah, because we would need, yep. Because if x is 0, 0 minus 2 is negative 2, times 2, we give us square root 5, so wouldn't have nice intercepts. Box. And really, the way that we go about sketching these, a lot of them, is really using the asymptotes. Because if I can find the overall box, the vertices, I can get the overall graph because of the asymptotes that will go through it. They have to come towards that vertice, but they cannot touch either asymptote. They're going to go towards them. So we can actually get the graph that way. Eccentricity, I actually looked that up the other day, or this morning. Eccentricity of an ellipse is going to be E is equal to C over A. Gets larger or smaller. So as the eccentricity is closer to 1, it's going to be closer. As it gets closer to 0, it's going to be wider. Now, escape. Let's look at examples. More examples dealing with this here, because that's about all that they had with example problems. Okay. Our vertices are going to be 0 plus or minus 2. And our foci is going to be 0 plus or minus 4. So if you haven't finished the ellipses, if we want to find the center, I'd say using the midpoint. It's actually a little bit easier than what we were doing. Well, both of these here, the value of h is going to be 0. Now we know that the equation that we're actually going to be using is going to be our y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Now if we want to find the midpoint with v, our vertices being plus or minus 2, well, we can add the 2 together and divide by 2. That would be positive 2 and negative 2. They add together to be 0. Now we need to find the values of a, b, and c. Well, the vertices would be dealing with our a. So we need to see 0 plus what gives us 2 and 0 minus what gives us negative 2. 0 plus 2 is 2. 0 minus 2 is negative 2. And c, along the same lines, is going to be 4, because 0 plus 4 is 4. 0 minus 4 is negative 4. So far, well, we're going to have y squared minus x squared on top, because the center is 0, 0. A squared, well, 2 squared would be, now we just need to find the value of b. Well, b is going to equal the square root of 4 squared minus 16 minus. That's it. Questions on this here? Yeah, because, well, it could be both. Because here, what's staying the same for our two vertices, because they did the plus or minus, is our value of h. So when I look at the two vertices, this h is changing, this one is not. So we're going to use this equation. Or we can say, okay, 2 is positive, negative. We're looking at this one here. So it's a little of both. So we can look at what's changing and what is not. Vertices. 2, 3, and 2, negative 3. Foci. So our y would be first. And really, I would keep referring back to these formulas to seeing which one works. Since h is staying the same, then really in both of them, we're dealing with y minus k squared being the positive fraction. Now it also tells us that h so now we need to find a, b, and c. But we do need to find the center. Good point. 2 plus 2 is 4, divided by 2 is 2. Hey, we already found that. 3 plus negative 3. We don't even have to divide by 2. This is just going to be 0. 0 divided by 2 is 0. Now we need to find a and b. Well, since we know k is 0, vertices is dealing with a, well, what plus 0 is 3? 3. And what minus 0 is negative 3? 3. Same thing with c, we would get 6. So b, the only other value we don't know, we're going to be taking 6 squared minus 3 squared We can just do 6 minus 3, right? Value B is 5. No. Yes. Well, because it would be 36 minus 9.
So close. So close.
Because 27 plus 9 is 36. We're always one less.
Yeah, one less.
Yeah, I'll do the same thing if I'm not paying attention, because since we're subtracting,
It'll work perfectly.
it needs to be 1. If we're subtracting, it needs to be 1 more than the number, because it's all with base 10. Because 36 minus 10 would be 26. 9 is 1 less than 10, so we have to go up 1. So under Y would be our A, which would be 9, and B would be, that's it. Questions on this here? We feel okay with this here? All right. Vertices, 0, plus or minus 3. Asymptote. Y is equal to plus or minus 3x. Yes.
An A to 0. So your center would be 0, 0.
And this here we would have x squared minus. No. No, I have it flipped. Because since the y is what's changing in the vertice, because that's, I was just double checking my equations and I noticed vertice k plus minus a.
A3, B1.
So a is 3, so we do have 9. Now because of our equation for this here, y is equal to k plus or minus a over b times x minus h. Well, we know 0 plus or minus well, a, we know it is 3. Yes? And this here should be our equation. Yep. Questions on this here? We can do another one. We'll do another one. This isn't the only one that we'll do. X's. X is changing, Y is staying the same, so that means we'll have x minus squared minus y minus squared over equals 1. Now, if we do midpoint, because focus, still the center is at the middle of it.
Y is -1, right?
Yep, y is going to be -1, so in the equation it's going to be +1. -1 plus 9 is 8, divided by 2 is 4. So the center is at 4, -1. Now this also does help us get our C value, because 4 plus what is 9? 4 plus C is 9, so C has to be 5. 4 minus 5 is -1, so we do get our 2 values, so we get C. Now, with this here, either one of these equations, we're looking at y is equal to k plus or minus b over a times x minus h. I'm going to split it. B over a times x minus h. Actually, we don't even need to split it, because when I multiply by b over a, it's going to go straight to x. X does not have a number with it, so the b over a would stay the. So b, in our case, is a is. X minus 4 squared over 16 minus y plus 1 squared over 9 equals 1. That's it. Questions on any of this here? Now, there are some more on here dealing with the equations itself and finding the values given those equations for the vertices, center vertices, and focus. And it does ask you to sketch them. I'm not going to ask you to sketch them. So find the center vertices, foci, and the equation of the asymptotes. So these here for each of the given equations. Clear. Page 724. Problems. Even. Odd. Which gives you a whopping 12 problems. Yeah. I have